All right, let's talk about a supplement you probably think you know inside and out, creatine. But forget about bigger biceps for a minute. We're going to explore how it might just be the secret superfuel for your brain.
For years, creatine has absolutely dominated the gym scene, right? It's one of the most researched sports supplements on the entire planet. But what if its biggest benefits aren't for our bodies, but for our minds? New research is completely reframing creatine as a serious tool for boosting our cognitive game.
So here's what we're going to cover. We'll start by looking beyond the biceps. Then, we'll see what the highest level of scientific evidence says about creatine and memory. We'll ask who benefits the most and break down how it actually works as a kind of battery pack for your brain. We'll even lay out a practical protocol, and most importantly, we'll read the fine print to see what the limitations are.
Okay, let's get right into it. The whole conversation around creatine is making a big shift, moving from the weight room to the neuroscience lab. And the main focus now, its potential as a nootropic, a brain booster.
Now, the central idea here is pretty simple, but it's also kind of revolutionary. We all know creatine for fueling muscles, but it turns out there's a ton of evidence piling up that it plays a massive role in brain bioenergetics, basically how your brain manages its energy. And where there's better energy, there's the potential for better performance. So the million-dollar question is, can taking this stuff actually sharpen your memory? To get a real answer, we can't just cherry-pick a study or two. We have to look at what's called a meta-analysis. Think of it as a study of studies. It's considered the gold standard in science because it pulls all the data from lots of different high-quality trials to find the true overall effect. To do this right, scientists have to cast a huge net. One big 2024 review started with over 1,800 studies. From that massive pile, they apply these super strict filters, weeding out any weaker research until only the absolute best, most rigorous trials are left. It's all about finding that clear scientific signal amongst all the noise.
So what does a high-quality study even look like? Well, for one of the landmark meta-analyses in 2022, the rules of the game were really strict. First, every study had to be a randomized controlled trial, or RCT. That's where people are randomly given either real creatine or a fake placebo. It's the best way to prove something actually causes an effect. They also only looked at healthy people, just to make sure other issues weren't muddying the waters. And obviously the study had to actually measure memory. Okay, this chart might look a little intimidating, but it's an amazing tool called a forest plot. Let me break it down for you. Each one of those horizontal lines is an individual study. Now look all the way at the bottom. You see that little diamond? That's the big one. It represents the combined result of all the studies put together. And that vertical line in the middle, that's the zero effect line. The most important part here is that the diamond is completely to the right of that line. It doesn't touch zero at all. And in the world of statistics, that's how we know the overall effect is real and not just a fluke.
And here it is, the magic number from that diamond in the 2022 review, 0.29. This is called the standardized mean difference. Now, in statistical terms, that's called a small effect. But what's really important here is that it's a consistent positive effect. When you lump all that high-quality data together, the signal comes through loud and clear. Taking creatine does lead to a real, measurable improvement in memory.
But just saying a small positive effect doesn't really tell the whole story. The truly fascinating part, the part that makes you go, whoa, is when the researchers start slicing up the data. And the most shocking difference they found was all based on age.
And the difference is just staggering. In that 2022 analysis, older adults, folks between 66 and 76 years old, saw a massive memory improvement. Their effect size was 0.88, which is considered large. But then you look at the younger adults, from 11 to 31, their effect size was 0.03. That's basically nothing. It's statistically zero. This really pointed towards one powerful idea. Maybe the memory-boosting power of creatine really shines in the aging brain.
But wait a minute, here's a plot twist. And this is exactly how science is supposed to work. A more recent meta-analysis from 2024 found the exact opposite pattern. It showed stronger benefits in younger adults, but not in those over 60. Now, this doesn't mean one study is right and the other is wrong. It probably just means there are other factors we need to figure out. Maybe they used different types of memory tests, or maybe the participants were different. It just goes to show you that science is a process, and we're still putting the pieces of this puzzle together. Okay, so we've seen that there is an effect, even if we're still figuring out for whom it's strongest. But how does it actually work? I mean, how can this simple compound do anything for the most complex organ in the known universe? Well, the answer comes down to one word: energy.
This is honestly the best way to think about it. Your brain cells, your neurons, they are firing constantly, and that burns an unbelievable amount of energy. Creatine basically acts like a rapid recharge system, making sure those neurons are always topped off and ready for action.
So, the fancy scientific term for this is ATP buffering. Get this, your brain is only about 2% of your body weight, but it gobbles up around 20% of your body's total energy. That energy comes from a tiny molecule called ATP. And when you're thinking hard, your neurons are just burning through ATP like a muscle car burns through gas. Creatine's job is to step in and immediately recycle those used-up energy molecules back into fresh, usable ATP.
Here's a quick look at how that recharge system works. Step 1. A neuron fires. To do that, it uses a high-energy ATP molecule, which then becomes a low-energy ADP molecule. So a full battery just became an empty one. Step 2. This is where creatine, in its stored form phosphocreatine, swoops in. It literally donates a piece of itself to that empty ADP. And step 3, boom, that molecule is instantly recharged back into high-energy ATP, ready to power the next thought. This all happens in a fraction of a second.
Okay, so the science is promising, and the way it works makes a lot of sense. So let's get to the practical part. If someone wanted to try this, what would a science-backed protocol actually look like?
Well, the meta-analyses give us some pretty clear directions. The type of creatine that consistently gets results is the simplest, cheapest kind, creatine monohydrate, specifically as a powder. The standard dose is 5 grams a day, and what's really interesting is that the analysis found that taking more than 5 grams didn't give you any extra memory benefits, so more is not better here. As for how long, they saw positive effects in studies as short as 5 days and as long as 24 weeks.
And what about safety? I mean, that's always the big question. Well, creatine is one of the most studied supplements in history, period. And it's considered extremely safe for healthy adults. In all of the studies we've been talking about, there were no negative effects on memory reported whatsoever. All it's doing is supporting a natural energy system that's already in your brain.
All right, but no deep dive into science is complete without a little bit of healthy skepticism. If you're going to be a smart biohacker, you don't just follow the headlines. You have to understand the limits of the research. It's time to read the fine print.
This is how scientists basically grade each other's work. It's called a risk of bias assessment, and they use a simple traffic light system. Green means the study was rock solid, low risk of bias. Red means there are some major problems, and you can't really trust the results. And yellow, well, yellow means there are some concerns. And as you can see, there's a lot of yellow. It tells us that while these studies were good enough to get published, a lot of them aren't perfect.
So what does all that yellow actually mean? Well, for one, the studies all used this random grab bag of different memory tests. It makes it really hard to compare them. It's like trying to get an average speed when some cars are measured in miles per hour and others in kilometers per hour. A really big one is that most studies didn't measure people's creatine levels before they started. Think about it. A vegetarian is probably going to respond very differently than someone who eats steak every day. And finally, there's always the potential for publication bias, where studies with exciting positive results get published way more often than boring ones with no effect.
So, what's the bottom line here? Where does this all leave us? The evidence is genuinely promising. There's a real statistically significant signal that creatine can help with memory. But we have to be honest and say the science is not settled yet. To get a really crystal clear picture, we need bigger, better studies that all use the same memory tests and measure those baseline levels.
And that leaves us with one final, pretty exciting question. When you look at that incredibly strong effect seen in older adults in that one major review, could we be looking at one of the first truly accessible, affordable tools to help protect our brains as we get older? The science can't give us a hard yes right now, but it definitely gives us a very, very compelling maybe. Thanks for tuning in.